Okay, can I get your attention, please? Ladies, Leah, got it? You have to put your name in, yeah. So maybe you're already on the crew. Oh, weird. Okay, so starting this new unit of logs, we're going to use everything we learned from exponential functions and apply it in logs. So these two units, often they're taught as one unit because they're related. And I decided to break them up into 2 units. Okay, so most of you did fairly well on exponential functions, and that is foundational to logs. Okay? Yeah, if you struggled on that exam, you're going to struggle with this unit. So you might have to go back and solidify those concepts, get some extra help. So what's a log? Well, a log function's in the form. It's going to look really funny. A function in the form y equals log, and then we're going to have a little b there. Oh, sorry, a log. Forgot a in front. A log b of x. Okay, so how you would say this is you would say it log b of x. That's how you'd say that out loud. Okay, log b of x. And b stands for the base, and x stands for usually the exponent. Oh, sorry, no, what the answer is. But we'll practice going back and forth. So this is actually related to an exponential function. I know it doesn't look that way, but we're going to find that relationship after. So where a few conditions, a can't be 0, because if a is 0, what would happen to this? 0 times anything is 0, so it wouldn't be a log function, it'd be a constant function. Also, so a can't be 0, b can't be 1. Just like in our exponential unit, the base can't be 1, right? Because 1 to the power of anything is always 1, so it wouldn't be exponential. And b has to be greater than 0. The base has to be greater than 0. So think of the base as when we had the exponent, right? Like 2 to the power of x. The base is 2 here. So our base can't be negative. Okay. Everyone got that down? Yeah? No? That was a no. Got it? Good. Okay, highlighter. Use a graphing calculator to graph the log functions. Okay. Now, if you want to graph log 10 of x, what this means is it's base 10. So in your graphing calculator, you're just going to type in log x in y equals. Okay? So log, if you don't write a base, it's always 10. Like if I were to write log x, these are the same things. If I don't write the base, then we know it's a 10, a base of 10. So the common base, what we call the common base, where's the word? Common logarithm is base 10. So common logarithm is base 10. Okay, on the same axis, graph y equals 10 to the power of x. So grab your graphing calculators. Let's do this together. It won't take that long, trust me. We can skip a couple if we need to, okay? So make sure to zoom 6 when you graph. Oh, let's get rid of that ugly guy. Okay, so what I want you to do is log x. So that's automatically base 10, log 10 of x. So log button, sorry, is right by side 7, yeah. And then the next one, I want you to graph 10 to the power of x. So notice my base there is 10. 10 to the power of x. So we want to find a relationship between these two. Okay? Now, before you push graph, can you go over to the right side and push enter once? So this should be flashing, and then push enter, and this will make it bold. So we can see the difference between 10 to the power of x and our log of x. Okay? Now push graph, maybe zoom 6 if your windows are off. And our graph should look like this. So there's my log function, and there's my exponential function. Did you get the same thing? Yeah. Okay. So if I do a quick sketch here, so this is my exponential function, y equals 10 to the power of x, and my log function went like this, equals log x. Okay? So what is the domain of y equals 10 to the power of x? XER. Okay? What's the range of 10 to the power of x? The range. No. Y is greater than 0. What's the x? Is there an x-intercept on this graph? None. The y-intercept, what's the y-intercept here? Remember what it would be if our a value, if we can't see it, is 1. Y-intercept is 1. Or x is 0, y is 1. Okay. Asymptote. What is an asymptote? A line it cannot touch. Okay? You cannot touch my asymptote. That's right. Not appropriate. So, the line that it approaches but never actually touches would be this line, y equals 0. No? No, we're talking about for this graph, just for this graph. Just for this graph. Okay? Ignoring the log graph, for this guy, the y equals 0. So it's getting closer and closer and closer, but never touching. Okay, so let's look at the log graph now. What's the domain of this function? Does it ever go to the negative side? No. Is it ever going to touch 0? It gets close to it, but never will. So it'd be x is greater than 0. What's the range of this graph? Will it keep going up and down? Yep, YER. Is there an x-intercept? Yes, I'm going to tell you what it is. It's 1 and 0. So this is 1 here. Is there a y-intercept? Does it ever touch the y-axis? None. And the asymptote would be the line x equals 0. So these two functions are what we call inverses of each other. It's like all the information for the x and y have switched. Okay? So an inverse function, we also say, is a reflection in the line y equals x. If there is an imaginary line here, this imaginary line y equals x, it's reflected in that line. That's what inverse function is. Okay? All right, let's try another one. We're not going to do every single one. We'll take our time. Okay. We're going to choose 3 different a values. We want one of them being negative. Okay, so let's start with y equals 1 log x. Give me an a value, a different one. 2, okay, 2 log x, and we'll do negative 2. Y equals negative 2. That's a 1, sorry. It's a really ugly. So it's log, and this is just a 1 in front. No. No, it's not inverse. It's when x and y switch. Okay? Okay, so we're going to graph these on our calculator and state each. Let's go one at a time. So really quickly, we can clear this. We already have this first guy with our a value is 1. So if our a value is 1, what's the domain? I'm just going to change my negative 5 to 5. Might look prettier. X is greater than 0. X is greater than 0. Okay, what's the range of this graph? Y-E-R? Yeah. Goes forever up and down. It's going to go like this. It's kind of slow today. There you go. So there's our graph. Okay, so Y is an element of the reals. I'll keep going up and down. This actually keeps going down like that. Number of x-intercepts. 1. Y-intercept. None. There's none. End behavior. So, what's the end behavior of this graph? 4 to 1. Oops, sorry. Let's ignore that. 1, 2, 3, 4. Yeah, so it goes from 4 to 1. Quadrant 4 to quadrant 1. Okay, let's try the next guy. Try positive 2 log x. So if you can graph that. It's the same. Did anything change? It's just a little bit taller, but that's about it. How about the domain? Will that change? No. Range, will that change? No. X-intercept, still at 1. Y-intercept, none. 4 to 1. Okay. So let's just try the negative now. So now we want to insert the negative there. Negative 2 log x. Something changed here. So with these a values, we could say this log is increasing. Do you agree how it's increasing? Okay, so these two, when we had a positive a value, our function is increasing. A negative a value, we are now decreasing. Okay, so let me just take a picture of you. We have it. Okay, so turn that off. What's my domain? Domain. Spencer? Spencer, what's the domain? Still x is greater than 0. What's the range, Dennis? Y-E-R. Steph, what's the x-intercept? 1. There's one of them. How many y-intercepts? None. End behavior. Quad 1 to quad 4. And so that's our hint. It was decreasing. 1 to 4. Okay? So really quickly, how does the a value affect the graph? Well, if a is positive, as x increases, y, then what? Increases or decreases? Their positive a value. So as x increases, what happens to our y value? It's going up. It increases. Y increases. For when a is negative, our function looks like this. So as x increases, right, this is our x values, as x gets bigger, what happens to y? Y decreases. So we would say a negative a value gives you a decreasing function. A positive a value is an increasing function, which is nice. It makes sense, right? Plus or minuses. Vince? Huh. Okay, grab your graphing calculators. I want to teach you another thing. Ooh, where are you? Okay. So we've talked about the log, right? This log right here, beside the 7. So there's two types of logs. There's just your regular log, and it has, if nothing is written, it would be base 10. Okay, our number system, so those are the same thing, base 10. Okay. The natural log, has anyone ever heard of E? Oh. probably wouldn't look as healthy. Okay. So E is a constant, another irrational number. It's very popular in the math world, just like pi is. So pi and E, they're like best friends because okay, because oh, you guys. Yeah, so it's a constant. It's actually right here, e to the power of x. So easiest way to figure out what e is, or here's e right here. So second divided by symbol gives you the e constant, which is 2.71828182. Because you've never really needed it before until now. Okay? And so it's called a natural log. One of the reasons why it's such a special log is if you were to graph the equation of the slope, it would be the exact same line that it already is. So that's why it's so special. It has a lot of applications in math. And so a natural log, we use L of n. Ln. Natural log. Log natural. Okay? So Ln of x is the same thing as with base e. Okay? If we don't see the base, it's an e. So if it's just log x, it's base 10. But if it's a natural log, it's base e. Okay? So that's what we call a natural log. So if we were to graph these two functions, which I just did again, here's my e to the power of x, and here's log or natural log of x. I just plugged it in. Okay? Yeah, so you type in the button natural log. So instead, e to the power of x. No, it is very necessary. You'll see later on. Okay, e to the power of x, not 1. So e to the power of is just second of the natural log. And then natural log of x is right beside the 4. So if I were to graph these two, this is what it should look like. I think my windows are a little different, but pretty close. Okay, so again, these guys are inverses of each other. So these guys are inverses. So inverses of each other. Actually, if you could write that's not on this graph. I want you to draw this graph. Really, just a rough sketch. What's your question? If there's no base written, then it's a 10. Right? So if we don't see it, it's base 10. If there's no base here written, it's e. Yeah. So you can have a function that's like this. So this would be log 5 of 2. So that's base 5, not base. So it doesn't, if there's no base written though, then we know it's 10. Okay, so in an inverse function, can you draw? An inverse function is a reflection in the line y equals x. Reflection in line y equals x. So essentially the x's become y's and the y's become x's. They literally invert each other. So wherever my x-intercept was before, or y-intercept, they switch. They're completely switched of each other. Everything is switched. That's an inverse function. Sorry, this is a long, boring lesson. Yeah, there it is. It's really long and boring. I hear ya. We're okay. It's not that hard. It's just boring. I'll try and make it more interesting. Okay, does everyone have that down? Got it? Some of you still writing? A-okay? Jody, got it? Okay. Isabel, you got it? Okay. All right, so grabbing your graphing calculators again. We're going to graph natural logs. So let's just do regular natural log. Give me a number, an a value. 2, and then we'll do -2 again. How exciting. Okay, we're going to do this ultra fast. So I'm going to graph it, you just watch. Okay? So the first graph is just natural log of x. Graph. Okay, what's the domain of this graph? Oh, sorry. X is greater than 0. Okay, so we see that our graph, again, it's like a log graph. What's the range of this graph? YER, number of x-intercepts. 1. How many y-intercepts? How many y-intercepts? 0 or none? And behavior. 4, 2, 1. Okay, that's 1 done. Do you think anything will be different from this graph to this graph? No, so it's still a positive a value. So it's all the same type of behavior in terms of domain, range, number of x-intercepts, number of y-intercepts, and behavior. Okay, so what was the difference for -2? It's quadrant 1 to 4. So it's decreasing, right? This means it's decreasing function, just like we saw last time. Okay, and these guys are increasing because our a value is positive. And the rest is the same. Okay, so we could say the a value, all it does is tell us if the function is decreasing or increasing. That's all it does. Okay, so a, again, tells us if increase or decrease. Okay, when would it be a increasing function? Positive a value, decreasing would be negative. It just, okay, so let's look at the difference. All it does is the growth would be a little, okay, that's a little big. So let's try like 5, a little bit exaggerated. It's because of my windows, okay? So notice the difference. Yeah, it just grows, the increase is greater, right? A greater a value, a greater increase. Okay, so notice the difference. So the a value tells you how fast you're increasing or decreasing. It's kind of like the slope. Yeah, kind of like the slope. Fun, fun. Okay, let's skip this and go to, oh, actually, let's go back to 7. Okay, so an exponential function versus a log function. How are they related? They're inverse, which means they are symmetrical about where, Jesse? What line? Y equals x. The y equals x line. So we talked about that. This is the y equals x line. Okay, so the x and the y values are switched. So if the domain was xer, the range will become yer. The domain was x is greater than 0, the range will become y is greater than 0. All the properties switch places. Okay, we are almost done. We really are. We're going to skip 8. Yeah. I got a little bit of vitamin D this weekend. Not going to rub that in too much. Went to Vegas. And I got home at like 2. So.
Lose lots of money?
No. I bet money to lose it. I learned my husband might have a gambling problem. He won a lot of money. Took home like $500 or $600. But I was like, Pastor Dave, let's stay away from Vegas. He is that, or Furnace, but he also has his pastoral degree.
My uncle went to Vegas when he was stingy, but he was so sick when he went down, so he just had a relaxed trip. And then right when he was leaving, he actually put a quarter in the machine and he won $76,000.
That's a good day. Oh my gosh. See, that's what gets people addicted. Get one good win, and you're like, I want it again. Yeah, like just stay away from all that. All right. Super. That's awesome. Okay, so a couple of things I want you to highlight. If you have a highlighter or if you can underline this. So when we're talking about, this is a log function. Okay, so this is the definition of a log function. I don't know if you can read that. And those are the properties. Now, this is the characteristics. You should probably know all these characteristics. We've kind of seen them already, right? So this depends, the end behavior depends on our A value. Okay, and then bottom thing right here, if A is greater than 0, then we have increase. A is less than 0, decrease. So that's what we've talked about. Okay, so let's try looking at these. So looking at all 4 of these lines, you should be able to tell which ones are exponential and logs. So is this a log or exponential function? A log function. Remember, exponential looks like this. Okay? So if x is greater than 0, you know it's a log function. So this is an increasing log function. Okay? And this is where a is greater than 0. This guy here is also a log function because y is greater than 0. But it's decreasing. This green line is an exponential function. And what we just reviewed is that a log function is a reflection of our exponential function in the line y equals x. Same with a natural log, but it's e to the power of x. Two more questions and we are home free. Okay, for each one of these, I want you to state the x-intercept, the y-intercept, end behavior, domain, and range. Okay, so give those a shot. You can use your graphing calculator. You might not need to. You remember the properties. So give these a shot. Give them a try. So this will be a decreasing log. So it looks something like, without even looking at it, like that. Right? So what's the x-intercept? Always on a log function? 1. So 1, 0. Is there ever going to be a y-intercept? No.
There's never a y-intercept for log function, right?
Never in a log. Just like there's no x-intercept in an exponential. Yes, that's because yep. That's why some teachers teach the 2 units together. Yeah. End behavior from quadrant 1 to quadrant 4. Domain. X is greater than 0. Range. Y yard. Okay, this guy, without even looking at it, increasing or decreasing log. Right, so notice we're always starting near the x-axis or y-axis. You can use your graphing calculator. But you know that this is increasing, and so if you remember what an increasing log graph, you can just figure it out. X-intercept 1, 0, none. End behavior would be quadrant 4 to quadrant 1, and the domain and range stay the same as the other guy. So the last question, I want you to match the equation to the graph. Give it a shot. Okay, so match these equations to the graph. These given graphs.
I love these questions for my test.
You love them?
Yeah, you automatically said.
My tip for you is label the graphs versus logs or exponential. So like this guy, log or exponential? Log. This guy, log or exponential? Log. This guy would be exponential, and this guy is exponential. And then label your increase, decrease. So this guy, increasing or decrease? Decreasing. So who's a log with a decreasing log? Number 4. Right? Our A value tells you it's decreasing. This is a log, increase or decrease? Increase. So which one would that be? 3. Guys. Okay, now this is an exponential growth or decay? Growth. Review, Andrew. What tells me, what value in an exponential function, Andrew, tells me it's a growth function? Nope. The B value. So which one has a B? Number 1. Okay, and the last one, this is a decay. Again, we look at the B value for exponential. So number 2. All right. So homework is all of 7.1 in your workbook. Yeah, but luckily we have no quiz today. So we still have lots of time for homework. Okay? And I need to talk to a couple of you.